Hey Caleb, hope it went well or is going well in Florida. And we're going to pick up from where we were talking yesterday, and we're going to find out what situations we can make inferences and how broad of an inference we can generalize to. So, Brandon's going to be reading a story here to us. Go ahead.
Is it number 103?
Part 103?
Yes.
Mm-hmm.
Foster care versus orphanages. Do abandoned children placed in foster homes do better than similar children placed in an institution? The Bucharest Early Intervention Project found that the answer is a clear yes. The subjects were 136 young children abandoned at birth and living in orphanages in Bucharest, Romania. Half of the children chosen at random were placed in foster homes. The other half remained in the orphanages. Foster care was not easily available in Romania at the time and so was paid for by the study. What conclusion can we draw from the study? Explain.
All right. Just a second. All right, here's a gist of what we were supposed to analyze that in regards to this chart. So, which do you think do we have here? Was there a random selection of individuals from Romania? Was there? What do you think, Allie?
No.
Did anyone think there was a random selection? It did not indicate it was. So, you happy with that?
Did you say there was
Was there a random selection? Pardon?
in the first part?
Yeah.
Oh.
It didn't
Yeah.
say what I wanted to do.
It didn't, so I think it would have to say, we can't really assume it was random if they don't say it.
It said similar children placed in an institution.
Yeah, yeah, so that's pretty big, right? So I would say that's a no on random selection, so we're down here. All right, then, Brandon, what did it say? Did it say that there was treatment assigned randomly? The treatment was assigned randomly, whether you went into a home or you were remaining in we went into foster care or you remained in the orphanage.
Was it assigned randomly?
Yeah, was that randomized?
Yeah, I don't think it was.
Pardon? I heard the word random somewhere.
It says chosen at random.
Oh.
Yeah, see,
Oh, yeah,
it's
you're
just
right,
briefly stuck in
You're right.
there. All right, so that means we
Yes.
were all, there was no random selection in the process at large to actually gather participants for this study, but once they got the people, they did randomly select which quote treatment they went to. So, what can we say about that? Julia, what do you think we can do between cause and effect? We can say cause and effect, but we can't generalize. So how did you put it?
I said that you can say that living in foster care in Romania is better than living in
Right, so that's exactly right. Did everyone agree with that? She put it very well, because you hear her emphasize in Romania. She's not generalizing beyond that, but we can say that one does precipitate the other, so it does have a cause and effect relationship. All right, Allie, read about frozen batteries.
Is this actually true though?
Pardon?
Is the thing
Frozen
actually true?
batteries.
I don't know. I don't know. I feel like a lot of things in this book, the examples are. I mean, they're pretty convincing the way they word them if they're not, but.
Okay. Will strong batteries in a freezer make them last longer? To find out, a company that produces batteries takes a random sample of 100 AA batteries from its warehouse. The company's statistician randomly assigns 50 batteries to be stored in the freezer and the other 50 to be stored at a room temperature for 3 years. At the end of that time period, each battery's charge is tested. Result: batteries stored in the freezer had a higher average charge, and the difference between the groups was statistically significant. What conclusion can we draw from this study?
Right. So Elena, what block are we here? Was there random selection in the beginning? And then did they randomly treat those in the selection? Cool. So could you put it all together then, Elena? And what statement could we make?
So the conclusion is that batteries are more functional and they're stored at lower.
Right. Anti-battery. Actually, what's the population? You remember the very beginning of this mod, or chapter, sorry. The beginning of this chapter, we had to identify population, and the population in this one is all the batteries in that factory. So we can generalize to the population in the problem. So we can say all the batteries in the factory are last longer when they're stored in the freezer. So would you make that little tweak if you didn't emphasize, you see why I have to stay in the factory? Because the problem only goes to the whole population, and in this problem, the population are those in the factory. So don't go to every battery in the world, unless they were chosen randomly from the world. All right, another reader. Bailey, who talks more?
According to Luann Brizendine, the
Yeah.
author of The Female Brain, women say nearly 3 times as many words per day as men. Skeptical researchers devised a study to test this claim. They used electronic devices to record the talking patterns of 396 university students who volunteered to
Bad
participate in
word.
the study. The device was programmed to record 30 seconds of sound every 12.5 minutes without the carrier's knowledge. According to a published report of the study in Scientific American, men showed a slightly wider variability in words uttered, but in the end the sexes came out just about even in the daily averages. Women at 16,215 words and men at 15,669. This difference was not statistically significant.
All right.
What conclusion can we draw from this study?
All right, Julia, are we at a random selection? No? Was there a random treatment? No? So can we make any conclusion? No. Problem over. All right. So that was a quick one. Wasn't worth reading, was it? All right. The last one. Julia, read about attending church.
Attend church. Live longer?
Let's hope so, huh?
One of the better studies of the effect of regular attendance at religious services gathered data from a random sample of 3,617 adults. The researchers then measured lots of variables, not just the explanatory variable, religious activities, and the response variable, length of time. A news article said churchgoers were more likely to be non-smokers, physically active, and at the right weight. But even after health behaviors were taken into account, those not attending religious services regularly were still about 25% more likely to have died. What conclusion can we draw from this study?
All right, so we go to the charts. So help us again, Elena. Was this one, did they randomly select the participants?
Yeah.
They did. They had over 3,000 people, and they randomly took a sample of that. So random selection, yes. But after that, was there a random assignment of treatments?
I mean, no.
No, there wasn't. They
Because-
kind of observed, and that was it.
Yeah.
They didn't say, okay, you guys go to church and you guys don't go to church, you know. All right, so it wasn't. So we had a yes on this side and a no on this side. So we can not make a cause and effect statement, but we can make a general statement. I think this is the hardest block to put into real life. Did anyone, Bailey, what'd you come up with on that one?
I said, because the people were selected randomly, we can generalize that churchgoers are seen to live longer, but there was no random assignment to a treatment, so we cannot infer a cause and effect.
Right. So all we can say is we see that churchgoers live longer in this population, which was just the 3,000 and some, over 3,000, I guess. So that's all we can say is we see churchgoers live longer. We can't really say cause and effect because there could, like they said, there could be other things like not smoking or jogging, or maybe churchgoers do a lot of different life style habits than others. So, all right, you did very well on that. I think if you do it with the chart in front of you, it really helps, you know. So I advise you when you're testing and those kind of questions come up, we elected to take the test home with us and take it open book, open note, and then we will that'll be like a 50% of our test grade for this chapter, and then we'll have a project that I'll explain and talk about on the Monday returning. It's a short project, it's not a big deal, but it'll be the other 50%. All right. The other thing I didn't get to mention yesterday, do you have room on your day, what was that, 8 notes? Day 8, I think it was yesterday. Do you have room to add a thought? And that is, even though you do this chart and you do it right, sometimes your brain has to come and say some additional things to you. Like, is this result or conclusion? Suppose you did the chart and you got the generalization and you got the cause and effect. Is this conclusion, I don't know how to say it, real or,
Like reasonable?
yeah.
Valid,
Yeah,
valid.
or real or lasting, is it gonna last? Or what'd you say?
Valid.
Valid. What'd you say, Julia? It was good.
Reasonable.
Yeah, reasonable. All right, so let me give you an example of one that passed this test but didn't hold up. So, in other words,
Brandon.
it was random and it was random on both categories, so it should have held up, but here's what it was. Do you remember in 86? Anyone around in 86?
What?
Were you around in 1986?
Oh.
Well, in 1986, there were taillights on that's the back of a car.
Okay.
These are the taillights, and when the guy's braking, the lights come on, obviously. So before 1986, that is all you had. Then after 1986, they developed a law that said you had to have that other brake light that is up high. Is it in the windshield?
It's like, yeah.
It's up
It's
high.
above the windshield.
Usually, some cars like have it in weird places or.
All right, so they added that third brake light in the back that is raised up higher than the other two. And here's why. They had a well-designed study that was in this column, and it said that rear-ending accidents were down 50% when they did that. That's why in 1986 they made that law. It was worth it. 50% is huge. It's a very significant number. So, guess what happened after that? And now, third brake lights cause a 3% reduction in accidents. So, your brain can probably tell you why. Why did it stop mattering? Why did it matter so much in 1986 and then it stopped mattering?
Is it because everyone has it now? So
Yeah. It's like when they first came out, everyone's like, whoa, what's that light? You know, it was like it made a big difference. But now it's like we've seen one, we've seen a million, so it no longer registers as an important difference. So
What
we
if-
slam into the next car anyway.
What
But
if throughout the years, like all cars need to like switch to different colors,
yeah, that's true.
and then like
We
for
probably
a
have the
while,
same
it's like,
thing
oh,
happening.
There's a green light.
Yeah,
And
same
then
thing will probably happen. So as long as we do
I
it
said,
regularly.
I shouldn't do a green light, just
Yeah.
other colors.
Breaking green light. Go.
Oh wait.
Yellow.
Yellow.
All right, so do you see that sometimes this chart is not all-knowing? Sometimes your brain is bigger than the chart, so you may question results that the chart gives with well-thought-out processes like this one. So that's the way I wanted to end on that discussion. We'll finish up today with ethics. So I put down
Oh, I
on
thought you
the
said ethics.
ethics. So I put down on the copier that I wanted 10 copies, and I got about 30. So how many you want, Elena? 4? Good girl. 3? Thank you. 5? What a pig.